Hi everyone, welcome to today's webinar. My name is Isabel and I'm going to be the DSPT host today. And today I have with me Ricardo from DevOps Porto community. Hi Ricardo, how are you?
Hi Isabel, I'm good. How about you?
Fine, thank you. So today our agenda are going to be a little bit different. We're going to start with presentation of both communities. Then we're going to have the first speaker, Alan, followed by a short Q&A. After this, we're going to have Sebastian, also followed by a short Q&A, and then we're going to go to our closing remarks. Ricardo, the floor is yours.
Thank you, Isabel. So DevOps Porto is a community, as you all know, the DevOps word by now. So our goal is to build bridges between communities, and it started as a simple idea between development and operations, but it has spread to a lot more. So the idea is that we build bridges between development, operations, Q&A, all the communities, and that's the main goal of our community. So you can find us on any of these links. You can search our website. There's a lot of links. There's previous talks. There's slides. There's some videos. You can also follow us on Twitter, where we put a lot of content out. You can also go on Slack. We have channels for general chatting, job positions, and all of those good things. And you can just send us an email. And back to you, Isabel. I'm sorry, I forgot this about this one. So you can send us talk proposals to our email, like I said previously, and you can follow this link, which will give you later, and you could just make a proposal for a talk to our meetup. And back to you, Isabel.
So we have a small video presentation.
Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born. The first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.
So as you saw in the video, you can find us all around Portugal. Once we're able to get back together with in-person meetups, you're going to find us on Aveiro, Braga, Coimbra, Lisbon, or Porto. However, you can find us online also. You can visit our website. You have all the information regarding news, next events, partnerships, and many more. But besides that, you can also join us on Meetup, Facebook, Twitter, GitHub, LinkedIn, and even our Slack, where you can find all of us and get in touch with us. And without further ado, I'm going to introduce you our first speaker, Alan. Alan is co-founder and CTO of Data Sprints. However, Alan is also the co-founder of DSPT, Brazilian Big Brother, let's say this, Data Hackers. So if you do not know anything about them, go find it. So hi, Alan.
Oh,
how are you?
Hi, Isabel. I'm fine, and you?
Thank you. Me too. And Alan is going to talk about how to using cutting-edge open source technologies to build one of the biggest industrial data lakes of the world. So Alan, the floor is yours, and good luck.
Thank you. So guys, first of all, I have to thank you the invitation. Rui and Joanna have talking to me a lot about those communities, how we can join together and bring more content. Here in Brazil, I'm one of the creators and founders of Data Hackers. It's like the SPT, but here in Brazil. And we are talking a lot about how we can get closer those communities. And today I have this presentation. I'm a data engineer, so I hope that there is lots of people there that really likes data engineering, or maybe is working with data engineering, or data science that wants to know more about this field. And I'm showing you one project that we develop here in Data Springs, that is a data lake for industry, I still making industry, using these open source technologies. We are very close to open source communities, and we use these technologies to build this solution. So about me, my name is Alan Seni. I'm a co-founder and CTO of Data Springs. Data Springs is a consultancy firm that provides service in data science and data engineering fields. And I'm also co-founder of Data Hackers. Our community, we used to do a lot of events, and we build content like podcasts and boot camps. And I'm in this field of data and software about 10 years. And specifically, in these last 4 years, I'm working as data engineer. So what are we going to see in this presentation? First, I'm going to present you the challenge that we face in this client, and we're going to pass through all those basic things to give you understanding about the main goal of this project. So we're talking about what is a data lake, and about these tools that we use in this project, these awesome tools that we use and use in a lot of projects. We will see how we put everything together to build this industrial data lake, and see the results that we deliver to our clients, and the next steps that we are thinking in these projects. And we go to the Q&A and answer all those questions that you have. So first, the challenge. We have this industry, is a multinational industry with plants worldwide. They have plants in the US, in France, here in Brazil, in Japan. So they have this challenge to give the global managers the capability of see what is going on the production line. So they have all these plants and making these products of steel. And they want to know the problems and the measures and all of things that is important to they deliver their products to their customers. And this specific domain has a lot of problems. So we usually have to deal with blobs and arrays and complex data types. So it's specific to this domain that you have sometimes some curves that represents a type of the strength that the product has or not. And in this client in specifics, they are migrating from on-prem to the cloud. They have a lot of Oracle databases, and this migration was doing in all the time that we are working in this project. Those data sets that we working on, they are not so big data sets, but we have lots of restrictions about this, how we can put this data to everyone to see it. So they have complex queries with more than 200 joins. Is a mess, and we just we have to bring this data with just 15 minutes of delay, and the maximum response query is of 30 seconds. And the main problem that is that we have a very limited cloud budget for a year. So we have to think a lot about the architecture. We cannot use the tools that we see on the market, the cloud tools like Redshift or BigQuery, that is good tools, easy to use, but they is very expensive. And you guessed it, this problem is so big, the stakeholder name is Miracles. So the guy that we are in touch with us in these projects, we say in Portuguese, milagres, né? So this is a funny joke that we do inside our team. So how we build this miracle, right? First, we have to understand what is a data lake. So a data lake, in this definition of any above, a best practice leader at SAS. SAS is a company well known to about data. They have a lot of projects that deals with data and statistics and data science. She says this. Data lake is a data repository that holds a lot of data. And uh, this specific thing is very relevant for data lakes. The data is on raw state, but so data lakes don't care if the data is structured or not. The schema is only defined when you need to consume this data. So you can put all the data, and only when you have to read it, you should define the schema. So you can think that the data lake is Amazon S3, but not really. So data lake is a platform, and data lake needs some of characteristics, some features that we highlight here. Data lake has to uh, get tools of security to audit this data, and features of catalog and access the data, and data pipelines and orchestration. So all these things together make a data lake useful. With all these three things, we cannot say that we have a data lake. So basically, it's a platform that ensure that we can consume data in a safer and efficient way. So let's talk about these cutting edge tools that we use to build data lakes on data sprints. First of all, the first tool that I want to mention is Dremel. Dremel is a data lake engine. So Dremel makes a lot of the work that we have to do very easy to do. And the Dremel was built for the PMCs of Apache Arrow. They use Apache Arrow on behind the scenes. Is very user friendly and is an open source tool. They have an enterprise version, but open source has a lot of features that is enough to build the data lake. So like the features that Dremel open source has, SQL and API, so you can manipulate data with simple language, and they have the wiki to do all the catalog, and the main thing that Dremel has and is easy to use and makes this platform very useful for data lakes is that Dremel can connect to everything. So Dremel can connect to storage like Amazon S3, HDFS, Azure FS, some NoSQL databases like Mongo, Elasticsearch, and SQL databases like Postgres and MySQL. If you are using some cloud storage, Dremel can read JSON, CSV, Parquet files, and they have this specific feature that they call reflections. Reflections is basically a materialized view that Dremels can read all this data of all the sources and persist this data on a S3 bucket. So you can read the data really, really faster than when you carrying against these primary sources. So this is one example of the Dremel UI. This print is the Dremel beta. The Dremel is not on beta right now, but you can see that it is a very easy to use platform. So this thing is good because you can bring a lot of users to this platform, and you can bring a lot of users to see what the data means and to see what the data, how the data is is organized on your data lake. And another tool that we use that is not very famous also is DBT. DBT means Data Build Tool, is a tool built by Fishtown Analytics, and is a data pipeline orchestration. You can say that DBT is like Airflow for data analysts. This tool is also open source and have this version enterprise as a SaaS platform. And DBT, what DBT does, they have this strategy to use the MPP, so use platforms like Redshift, BigQuery, or in our case was Spark, to make all the ETL. So they bring all this parallel power to do this thing that is extract the data, transform the data, and load the data, everything using only the power of the MPP. So the DBT also have code versioning. They have the documentation about the pipelines and about the data sets that you are building with the DBT, and data lineage that you see all this transformation that DBT does, in what stage your job is running. They have data validation, so you can validate your data in a semantic way, in a syntactic way, and they have seed data also. So you can make all those things with DBT. This is one screenshot of one of the screen. So you can see here that DBT lists all those jobs. So it's very close to what Airflow does. On the right side, we can see that the DBT builds the data lineage of the transformation, right? So how we use all these things together to build the data lake? We use DBT for pipelines and data orchestration. In this specific case, we use Dremel for catalog and expose the data, do all the access to the data. And we use basically Amazon S3 and Spark to do all the storage and the processing thing. Here we can see a very simplified diagram that represents what we build. So here we have the data that is arriving from another project that is collecting this data from the databases on-prem, and all this data was manipulated by a Spark job that runs on Amazon EMR. And all those things that are running here in Spark are orchestrated by DBT. So DBT that runs these jobs, that gets the data from one bucket, do some transformation. This first transformation is to repartition the data and do the schema evolution. So this specific feature is very important for the data lake, because we are always getting data, and this data can change the schema, and we must change the schema to the user also. So we are getting raw data, but the data has to be schemed sometime. And here we get another bucket and we do some optimizations in the data. Mainly we do some partitions, transform the data in Parquet and do some optimizations in the Parquet file. Then we get this data to another bucket, and here Dremel can read this data. So Dremel is like a portal. After all those manipulations that we do on the data, Dremel can see these data sets, that is huge data sets with lots of columns, and all the manipulations that the user here does, Dremel is the tool that perform this transformation. Here we have two layers more. We have this data port that is a layer of security, and data explorer. This is basically a part tool built for this specific user. So Dremel is the one that brings the data to the final user. And what we have of all those projects, right? So we built all this platform on 6 months with a team of 4 engineers full time. So it was a project that runs very well, and we keep the budgets very low, respecting this constraint of the clients. And here we can see that all those mostly queries are executed on a small timeline. So anything about less than 10 seconds, the most part of this query are running. And here we can see that we have a lot of concurrent queries at the same time, pushing up Dremel, and we have good results. So we have the mean here that is respecting this constraint, that we can't have response time bigger than 13 seconds. And in the next steps, what are we thinking to change in this platform in the future? So we are integrating Dremel with another analytics tools like Power BI and Tableau. So the Data Explorer still are going to be used, but we like the idea to use another tools, so we can make this solution more democratic and deploy all these analytics tool worldwide. And we have some problems to deal about latency, but we are dealing with this. Another thing that we are doing is to plug data science model to the data bus, the Dremel, to read data of the data lake and make some prescription, even to train new models with the data that is exposed by Dremel, and do all the data quality monitoring. So with Dremel, we can make some specific queries and see if the data is deteriorating or the data is getting better, and send some alarms to the people that are producing this data on the production line to see if there is anything wrong, and they can change all these things. So that's it, guys. I'm going to ask you to join us in Data Hackers. Data Hackers is the biggest community in Brazil. We discuss data science, machine learning, data engineering. We have a lot of contents. We give first for the community, so we produce content mostly on Portuguese, but we have content also on English. So you can find Data Hackers on these links or on Spotify, our podcast. And that's it, guys. We can go to the questions.
Thank you, Helen. Really, thank you very much for your talk. Well, if we were in a physical meetup, something like this would happen. So really, thank you.
Great, thank you.
We have a couple of questions. Maybe I'm going to start with the first one. That is, would you do something different if you had more budget? Because you guys really did something like fantastic with few budget and few people working.
Yeah, so definitely. We at first we will not use these tools because these tools is we say that is very new tools, and the community that is using these tools are not so big, and maybe if we had more budget, we will choose some tools like Redshift or BigQuery that can provide to us a specific support, and we have more professionals, specialists in these tools, and maybe we can build these things without to having some struggles that we have through the project.
Yeah, sure. Then I'm going to ask you the other way around, meaning that, okay, with the same budget, would you still doing something different according to the knowledge that you gained from it?
Yeah, for sure. So the main problem that we have was that we are trying right from the beginning, solving all those problems with Dremel and the Dremel features like reflections. But we have seen that Dremel is not so good to do some larger queries and some processing things like Spark can do. So maybe we at first we use Spark to do all those pipelines like we do after, and in that way we spend less time to give the customer the result that they really want.
Nice, really interesting. Let's go to another question, shall we? So some people are asking how the data versioning is being controlled and how do you monitor the quality of the data?
So in this diagram, I have not shown that we are using some Dynamo tables to track all those transformations that we do to get data from one bucket to another, and we use Dynamo to register all those data evolutions. So, and the quality of data, we use Dremel. We have some stages inside the data lake that expose some data sets on Dremel, and we use Dremel to read this data and see if the data is right and the quality is good. So we are using Dremel itself to measure the data quality.
Okay, thank you. And how about the DBT models? How are you running them? With DBT Cloud or?
We are running the open source inside the cloud of the client. So this client has specific restrictions about using platforms that read data and take the data off the platform. So we are using the open source inside the cloud, the AWS cloud.
Okay, maybe one last question. No, we still have time, but maybe a curiosity. How do you guys, what type of pain points do you guys have? What thing that you really say like, okay, I was like crashing my head against a wall because of this?
Yeah, we had facing some problems that even the people from Dremel, we are a partner of Dremel, and even the engineers of Dremel wasn't able to respond. So choosing these tools that is really cutting edge needs that you needs your team to be very prepared to use it. So if we have seen before that we are using these tools in a specific, we have done some trainings with the team and be more prepared to facing all those problems that we had faced. So I think the main thing that we should do in the next time is to prepare more our team for use these specific tools that is very new and very complex to use.
Okay, and then following up that question, would you give any type of feedback or any advice for people that are starting some projects similar to this?
So I think the main thing is that you should really knows about the main concept that drive data engineering. So all those tools, Spark, Dremel, Hadoop, has these specific features and they represent a concept behind. So you can have a lot of concept about parallelism and about how the data is stored in the cloud. So have these concepts really sharp on your mind is very important. So you can prevent to have some struggles with new tools. You can use new tools, but they are really like each other, but you can only understand that if you have a good understanding about parallelism and distributed database, NoSQLs, and how they work.
Yeah, that's really, really interesting how you guys were able to build something like this in a short period of time and with so like not many people. We have one other question that is regarding Dremel's performance and Haddock queries versus BI, like Power BI queries. Do you spend a lot of time manually creating data reflections?
Yeah, we have tried to use the reflection in the first time, but we see that reflection in this time that we are using are bringing some problems. So we have seen that the Parquet files were they were not have been constructed in a proper way, and we choose to do all those things manually with code in Spark. So Dremel was not so good in do the ETL thing. About the BI tools, well, so how is your performance in that queries versus BI? So Dremel is very performant. If you compare Dremel to Power BI and all these things that Power BI and Tableau does, that reads the data, then imports the data, then you can use it inside their platform the data. Dremel is very, very, very upfront of these tools. And these reflections that we are using, when we build it, we use the API of Dremel to build it. So we didn't expend so much time to doing this. We use the API and build some framework to do this thing in an easy way.
Okay, thank you. I think we don't have any more questions, but thank you, Alan. Really great talk, and I hope we have you soon again, talking a little bit further how this worked.
Thank you, Isabel. It was a great talk. Thank you all of the community, Rui and Joanna, and I hope that we see each other again.
Thank you. And right now I'm going to pass the word to Ricardo to present our second speaker.
Thank you, Isabel. So our second speaker is Sebastian Ramirez. You might know him as the creator of FastAPI or Typer, very known projects. He's a developer at Explosion. And I would like to start, Sebastian. I know that the Q&A is at the end, but I saw a tweet from you a while ago where there was a job position for something that you created 1.5 years ago, and it required 4 years of experience. So do you have any insights into how could you gather that experience in such an amount of time? I don't know. Maybe if you don't sleep, it counts as more work days. I don't know.
Yeah, I don't know. Like I have built a bunch of tools for developers, and it seems like the thing that got the most attention was that tweet that a lot of people liked. Yeah, I don't know. It's a fun world we live now, where some companies keep asking for a lot of experience when like the latest tools don't even have that much time existing. But yeah, that was fun.
So Sebastian's talk will be an intro to FastAPI, and then without further ado, I'm passing the word to Sebastian. Sebastian, the floor is yours.
Thank you very much. Awesome. So we're going to see an intro to FastAPI. FastAPI is a Python framework for building web APIs. It has high performance, it's easy to learn, it's fast to code, and it's ready for production. So a little bit about me. I'm Sebastian Ramirez. I'm a developer at Explosion in Berlin, Germany. I'm actually from Colombia. That's why the accent. You can find me on GitHub, LinkedIn, Twitter. I work for Explosion. Explosion are the creators of Spacey, the natural language processing toolkit for doing things like machine learning over text, and Prodigy, the package for doing data annotation with active learning for annotating machine learning datasets. Think the deep learning framework using ideas from functional programming and type annotations from Python. I created FastAPI and Typer. We're going to talk about FastAPI now. So a little bit about FastAPI. It has around 19,000 GitHub stars. It's been growing around 1,000 stars per month, I think a bit more. It's currently used by Microsoft, Uber, Netflix. So people have been liking it. That's great. And the performance is in the top rank for Python frameworks. So FastAPI is based on standards like OpenAPI, JSON Schema, OAuth 2. And because it's based on standards, it's compatible with a lot of additional tools. For example, you can have automatic API documentation like this one that you see on the right side. And FastAPI provides it by default because it's all based on standards. This documentation is actually provided by Swagger UI, which is another open source tool. But then you can get that for free just because it's based on standards. So when you create an application with FastAPI, it's based on standards for free. So FastAPI is based on Python type hints or type annotations, like this one. We are saying here that name is a string or that price is a float. We are going to see an example like this a little bit later, but the important thing is that these type annotations are what provides autocompletion everywhere in your code editor, and are what provide type checks and type errors in your editor, like these curly red lines. So when you use FastAPI, as you are using types everywhere, you get autocompletion everywhere in your code, and you can make this happy face. So FastAPI is easy and short. This is a completely valid FastAPI application. This is a complete API. From FastAPI, we import the FastAPI class. We create an instance of this FastAPI class that we are calling app. Then we use app with a decorator, which is this @ symbol here. We use this decorator on top of a function. That means that it's going to use this function from below. And what we are declaring here is that when someone sends a request to this path, to the root path, using an HTTP GET operation or an HTTP GET method, this is the function that we want to handle that. So it's very similar to, for example, Flask, if you have used it, just that we are declaring the method that we want to use right away in the declaration. So it's a combination of a path and an HTTP operation. So this whole thing, I'm going to call it a path operation. Then we are just returning a plain dictionary. We don't have to create an instance of a sophisticated class or something. We just return a dictionary, and FastAPI goes ahead and converts it to a JSON payload. In this case, we are using async def because FastAPI is underneath an async framework, but you can actually use normal def. We are going to see an example of that a little bit later. So FastAPI is very easy and it's very short. The amount of code you have to write to create an API is very short. So the more FastAPI code you write, the less API code you write, because most of the code that you write is going to be dedicated to the business logic of your application or the things that you actually want to write, the code of your system. FastAPI will get out of the way. That's the idea. So let's now check a basic FastAPI app with a little bit more of stuff. So this is more or less the same that we had before, just that now we are using a normal def function. FastAPI will go ahead and run this on a thread pool, so you are safe from blocking the main loop. It's not going to happen. So it will do the smart thing. So if you don't know about async and await and that stuff, you can just use normal function definitions and it will all just work. Now we are declaring another path operation here. And we are going to use, the path is going to be /items/, and now we're going to pass a path parameter that goes between these curly braces. These curly braces are the same ones that we use for F strings or formatted strings, so it's easy to remember what is the syntax that you are going to use here. And then this path parameter, we're going to declare it as a function parameter here inside of the function definition. And we are saying that item ID that goes here is going to be an integer. This is a standard Python type annotations to say that this variable, this parameter that goes in the function is going to be an integer. So this item ID, if we were calling it in this URL, it will be the equivalent of this parameter item ID will have this value 5. And then FastAPI is going to take care of converting this 5. If you see, this is coming from a URL. And in a URL, this 5 is natively a string. But FastAPI will go ahead and convert this 5 and convert it to an integer, so that the thing that you have in your code here is actually going to be what you declared. It's going to be an integer. And now we're declaring this extra parameter q, which is a string, and by default, it's none. Because this q is not part of the path, FastAPI will know that it has to read it from the query parameters. So the thing that goes after the question mark, we have a key, which is q, and a value, which is some query. So this parameter q is going to have the value some query when we call this URL. And because by default this is none, then this q parameter is going to be optional. It's not going to be required. And then when we write some code like this, and we go to this URL, we go to, well, not this URL specifically, but wherever you have your application, you are serving your application. If you go to /docs, you're going to see an automatic user interface that documents your API, like this one. So we have the first path operation that we created, and the next one that we created. You can see that we have /items/, we have the item ID, which is this path parameter in the curly braces. And the item ID is this same item ID that we have here, that we can see that is required. It's an integer and goes in the path. And then we have the q, which is a query parameter, which is a string, and we can see that it's not required. So we get this interactive user interface documenting our API for free. So you write some basic code with FastAPI, and good guy, FastAPI goes and makes a docs user interface for you. So let's now create a basic FastAPI app with a body. We want to receive some data in the body of the message, in the body of the request. So FastAPI is all built on top of Pydantic. It's integrated and built around Pydantic. So we're going to, from Pydantic, we're going to import base model, and then we're going to create this class base that inherits from base model. You can see that this syntax is very similar to data classes if you have seen them. Otherwise, we're going to check this on a bit. Now let's quickly jump to this part and we'll come back to the class. So we are declaring that we're going to receive a post request. So this is an HTTP post method because we want to be able to receive a body, a JSON body. Then we declare a parameter food, which is of type food. So this is the standard syntax in Python to say that this parameter food is going to be an instance of this class food. So this is how we declare it. And FastAPI will take care of giving us an actual instance here of this class food. So we're going to have an instance inside of our code, and then we can do food.name because we declared that this food had a name here, and then we can use it internally. Now, how are we declaring this class? We're saying that we want to have a name, which is a string. This is a standard Python type annotations. So this is the standard way to say that the name should be of type string. And ingredients is going to be a list of strings. Now check this list. This list has a capital L, and we are taking it from here. From typing, we import list. Typing is a standard Python module, and this is the standard way that you use in Python. This is standard syntax to declare that ingredients is a list of strings. And by default, it's an empty list. So the cool thing here is that we are using standard Python type annotations. You don't have to learn any new type of class or any new type of thing to declare that something is a string or a list. You just use standard Python type annotations, and FastAPI is going to extract the necessary information from them. So on one side, you're going to get like the standard benefits of type annotations. On the other side, FastAPI is going to convert the data for you, and it's going to document the API for you. So if we declare this like this, and we go to the same URL for the documentation, we're going to see that we have now it's an HTTP post request and goes to /food/, and the message, the request body that we are going to receive is going to have the shape that we declared. So we say that we wanted to have a name that should be a string, and ingredients should be a list of strings. And you can see the square brackets here. So this string is ingredients is a list of strings, and we are receiving all this in a JSON object. You can see curly braces in here. JSON object is the equivalent of a Python dictionary, and this list of strings is a list of strings in Python. In JSON, the term will be a JSON array, but it's basically the same thing. The cool thing is that we get automatic documentation from that class that we created. Now let's say, let me go back for a second. Let's say that we click this try it out button. Then we are going to be able to interactively to interact with our application, to use it interactively. So we can send an actual request. In this case, we're going to send the food that we are going to send has a name taco. The ingredients are frijoles, carne, taco shell, and sabrosura. And if we execute this request, this user interface is going to actually, that is running in the browser, is going to actually go and talk to our API that is running live. It's going to send the request, and then we're going to receive the message back. So we can interact with our API live from the documentation interface. And when we send a request body full of tacos, this is the face that your application is going to make. So now let's say that we want to create a basic FastAPI app that has a body, right as before, and a query parameter. So we just do the same that we were doing before. We declare food, which is of type food. This is the same thing that we had, and we just add the new parameter to the function. So we have this delivery, which is a Boolean. By default, is false. And because delivery is of a simple type, it could be a string, an integer, a Boolean, FastAPI knows that it has to read it from the query parameter instead of the body. And FastAPI is going to read it from the query parameter, and it's going to make sure that what we receive is an actual Boolean. So it's going to be false or true. It's not going to be like a string or a number. It's going to be an actual Boolean, the thing that we receive. And with this, if we go to the documentation, now we're going to see that we're going to have the documentation updated, and now we're going to have this delivery, which is a Boolean and should go in the query. And because we declared that it should be a Boolean, then the user interface is going to be able to let us, it's going to show us and present us the only two possible values for that parameter, which are just true and false. And this is how we will use it in a URL. After the question mark, we will pass delivery equals true. And then FastAPI will take care of converting this thing here to an actual Boolean in our code. So you don't have to put everything in the body. You can put parameters in the query. if you want to and if you need to. Now, let's say that we want to receive a JSON array of JSON objects in the body. So this will be the equivalent in Python of a Python list of Python dictionaries. The way we do it is the same way we have been doing with standard Python type annotations. So remember that this was a list of strings. Then here in our function definition, we can declare that we are now going to receive not a single food item, but an orders list of instances of food. So FastAPI is going to make sure that we have an actual list of instances of this class that we created here. And then, because we are going to actually receive a list of orders, then we can iterate for each food in orders. And then because we declare that food has a list of ingredients, then we can iterate for each ingredient in food.ingredients. And then here, the code that we are doing here is not very important. We are just collecting all the ingredients in this big list, and we are just adding the ingredients in lowercase, and we are just returning it. The important point is that we are going to receive the thing that we declared with standard Python type annotations. So we are going to receive a list of food items, and each food item is going to have a name, which is a string, and optionally an ingredients, which is a list of strings. And remember that ingredients is by default an empty list. So ingredients is not required because it has a default value, but name is going to be required. Now, if we go to documentation, it's going to be updated. And we will have now that this should be a list or a JSON array. You can see the square brackets here that inside should have objects like this one that have the name, string, ingredients is a list of strings. So we have this automatically updated. And the same way we can declare like deeply nested data structures as complex as we need them. And FastAPI will do the right thing for us using standard Python type annotations. So if you want to have JSON objects and you want to have them inside of another JSON objects, FastAPI lets you do it, and it's all using just standard Python type annotations. Now let's see what happens if we, so up to now, with the standard Python type annotations, we get like the normal benefits of Python with type annotations. And we also get data serialization. So like data conversion, we get the actual data types that we declare. If we say that something was a Boolean, we're going to get a Boolean. It's also doing data documentation, like API documentation automatically. But what happens if we send invalid data? This example is invalid. I'm gonna let you take a look. This is actually valid JSON. So the format is correct, but the data is incorrect. If we execute this query, then FastAPI is going to return us, like your application built with FastAPI is going to return an error telling us that the data was invalid. And it's not going to only tell us that there's an error in the data shape. It's also going to tell us exactly where the errors are. So let's check the first error, this one. It says that the location of the error is in the body, inside of orders, in index 2. Where is index 2? Let's check that. So this is the thing that we send. This is index 0. Index 0, name is a string, ingredients is a list of strings. This is fine. This is index 0, right? Now, index 1. Index 1, we have a name, pizza. We don't have ingredients, but we declared that ingredients was an optional attribute because it has a default value of an empty list. So this one is fine as well. This is index 1. Now, index 2 is this one. So the API is telling us that we have an error here. Now let's go forward to the error again. So we have the error here in index 2, inside of ingredients at index 1. And the error is that a string type was expected. Let's check that. Let's go back. So at index 2, inside of ingredients, so is this list over here, this list. At index 1, this is index 0, which is a string, that's right. And index 1, a string type was expected. And what we have is, oh no, a sneaky object. We have a JSON object here. So it's not only going to detect that we have invalid data, no matter how deeply nested the data is inside of the data structure that we declare and that we are sending, it's also going to tell us exactly where the error is. So that is going to save us a lot of code. Now let's check the other error. Let's go forward to the second error. So this one is in body, again in orders, index 3. And the error is at name, which was a field required. Now let's go back to the request. So index 3 was this one, and name was required, but we didn't send name. We sent food name. And we said that name was a required attribute. So this one doesn't have it. So this is an error. Let's now go back to the code, back. Here we are in the code. Those errors and that automatic validation is going to save us a lot of lines of code in this region. I don't know, 20, 50 lines of code, because by the point this code starts to execute, FastAPI already made sure that the data is valid and that we have exactly the shapes that we declared that we are wanted to have. So FastAPI is going to do data validation even for deeply nested data structures for us for free, and it's going to document it and do all the thing using Pydantic and using these tools, using just standard Python type annotations. Let's go forward. We were in the error, so we get validation. Nice. If we said invalid data, your API is going to make this angry face and it's going to say, no, I don't want to work with invalid data, and will protect us from executing our code with invalid data. Now, I have been saying that types and autocompletion and stuff, this is how autocompletion works, because we are using standard Python type annotations. So check this. Orders is a list of food instances. So when we iterate for each food in orders, your editor, your standard editor, is going to know that food is an instance of food. And then, because we know that an instance of food will be this class, we know that food has an ingredients, which is a list of strings. So then when we iterate for each ingredient in food.ingredients, your editor is going to know that ingredient is a string because it's part of this list of strings. So we are going to be able to have autocompletion even for this item here. We're going to have autocompletion for a string. Your editor is going to know that this is a string. And notice that we are inside of a double for loop. This is something that is not easy to achieve if you don't have standard Python type annotations. And we are getting this all for free for any complex and deeply nested data structure. Also, notice that this food item, this is not part of FastAPI. This is not something that we imported from FastAPI. This is our own data, the data of your application. With the attributes that you declare in your application, like you're going to have autocompletion for your own data and for your own code and your own application. We also get type checks. So because your editor knows that ingredient is a string, then when you do a string plus 5,000, your editor is going to know that this is an invalid operation. So it's going to show you an error like this one right away, right there in the error, telling you, hey, you cannot sum a string and an integer. You have to fix this. And you're going to see this error exactly at the point where it happens in your editor, even before you have to run your code. So it's going to detect a lot of errors just because you have these standard Python type annotations. And this is all because it's all based on standard Python types. Now, let's say that we want to add some metadata. We have this delivery query parameter, which was a Boolean. By default, it was false. But we now want to add a description saying that this means that we want to pack for delivery. So to add this description, we import query from FastAPI. From FastAPI, we import this query thing here. And then instead of saying that this delivery is going to be by default false, we say that delivery is going to be by default this query thing that we are calling. And then we can pass the description to query. And because we are taking the spot that was used for the default value that before was false, then the first parameter that we pass to query is going to be that default value. So we can pass false here. This false is going to be the default value of this delivery query parameter. And then if we go to the documentation side, we're going to see that delivery, now we have the extra documentation. We have the description that this means that we want to pack for delivery, that the default value is false. So we keep that default value of false. And this is still a Boolean query parameter. Nice. So we don't have to write documentation outside of the code. You can just keep the documentation and the descriptions of the things that your code is doing right there in the code. So you don't have to keep maintaining an external wiki or a shared document, or keep fighting with the front-end team or the other team because your API changed, or all those things, because everything is just documented automatically for you right there in the code when you just add the declarations there. Now let's say that we want to have a required query. We want to say that we want to ask for a quantity and it is required. It should be an integer. This is a query parameter because it's not in the path, and it's a query parameter because it's a simple data type, like an integer. To make it required, we just don't pass a default value. So this is just going to be required. Then when we go to the documentation, we are going to see that quantity is a query parameter, which should be a string, and it's a required parameter. If we try to execute a query like this one without passing a quantity, the user interface is not going to let us. And if we did, then FastAPI will also give us an error like the one we saw in a little while. So we get to have this quantity, which is a required query parameter. Nice. Then this is the phase that your IP is going to make when you omit required data. If you say that the query parameter quantity was required and you don't send it, then you're going to make your application angry, and it's going to complain that the required data was not there. Now what happens if you send valid data? This is how the URL will look like. So we say that we require quantity is equal to 2, and then FastAPI is going to take care of converting this 2 to an actual integer because that's what we declared. And quantity is required. If we execute it, then we get the response right back as we were expecting it, without problems, because we have valid data. Something to have in mind: one does not simply make all query parameters required. This is not common, and it's not going to be familiar for your clients. So just be careful with that, but you can if you need to. Now let's say that we want to add extra validation to this quantity. We want to make sure that the value is greater than 0, because we don't want someone to ask us for -1 plates or something. So we want it to be greater than 0, and we want it to be less than or equal to 10. To do that, we use the same query thing that we were using before, that we were using for delivery, and then we can pass these validation attributes. But now we are using this equal and something. So we now have this quote-unquote default value for quantity. How do we tell FastAPI that quantity is still required? So the place that query takes the first parameter that we pass to query to tell that something is the default value of some parameter, then we just pass these 3 dots. This is valid Python syntax. This is a symbol called ellipsis. It's part of Python. And this is the way we tell FastAPI, hey, this thing is still required. We want this quantity to still be required. And if we go to the documentation, we can see that quantity is still required. It's still an integer. We still have the delivery thing. And if we pass invalid data, then FastAPI is going to go ahead and validate the thing and tell us, ensure this value is greater than 0. So we get valid data. We get validation, extra validation, apart from just checking if it's an integer or a Boolean. We also get these types of validations. So this is the phase that your API is going to make if you send invalid data. It's going to growl at it, it's going to bark, but if you send valid data, it's going to be super happy about it and will process your code with valid data. Now, a little bit about FastAPI performance. I say this was in the top rank for Python frameworks. This is a benchmark run by Tech Empower, which is a third party. They benchmark a bunch of languages, frameworks, and things. This chart that I'm showing is filtering Python and Golang, the language. Go is a compiled language, so this is not a fair comparison. Go is going to be faster than Python like every time because Go is compiled. It should be faster. Otherwise, there will be a problem. But then we can see that a bunch of Python frameworks here, the blue lines, a bunch of these get to be a little bit faster than some of the Golang frameworks. So this is quite good, and we can keep Python and the Python tools that we are already familiar with. Now, which one of these is exactly the fastest is not necessarily that relevant. They get kind of on the same ballpark. In fact, FastAPI is built on top of Starlet. That's why FastAPI is so fast, because it inherits the speed of Starlet. And then all this is run through Uvicorn. So Uvicorn is the server. So Uvicorn should actually be on top of everything else, because Uvicorn is running everything here. So I think is that this has some random noise, but the important fact is that you get on the top rank for Python frameworks. You can see that Flask is somewhere here below, and then Django will be somewhere over here. But you get like a nice performance. And as you can see, we have in this specific benchmark, we are being able to handle 15,000 requests per second. So it's over 9,000 requests per second. That's cool. Now, FastAPI has some other features, like a dependency injection system is very simple, but very powerful. You can use it for doing authentication, authorization, and a bunch of other things. That is all integrated into the same automatic documentation that we were talking about. There are security tools for doing OAuth. OAuth2 is the set of standards and technologies to do things like authenticate with Facebook or Twitter or GitHub. Like they all use OAuth2 underneath. So you can build tools like that and applications like that, or integrate with them. There's support for WebSockets, because FastAPI is an asynchronous framework underneath. You can handle files, receive or send files. You can have lightweight background tasks for things like sending a notification email or things like that. There's easy GraphQL integration. There are a bunch of other features like templates with Jinja, a bunch of other things. Now, when is not necessarily a good idea to use FastAPI or to migrate to FastAPI? Let's say you have a stable Django application or Flask application or some other framework, and it's already stable. You don't need to add new features, and it's not an API. For example, you are based mainly on templates or things like that. Then in that case, FastAPI is probably not going to be a good idea, because you're not going to get a lot of benefit from that. If you have new features, if you have new things, or if your application is actually an API, then you'll probably get some benefits. One thing I would recommend, if you want to try FastAPI, you want to add FastAPI on top of your existing application, you can add a little layer and then add a proxy on top of both of them. And then, for example, send some requests for the new features to FastAPI and the rest to your stable application in another framework. Or you can, for example, even integrate the same ORM that you are using in your existing application with FastAPI. Nevertheless, there are some teams that have just gone ahead and migrated everything to FastAPI, and they have been happy about it. But I wouldn't necessarily recommend that, because if you have already something that is stable and working very well, then maybe that's not the best use case. Cool. Some other tools that you might want to check. Typer is more or less the same as FastAPI, but for building command line applications, things that run on the terminal. And the users of your application are going to get for free shell completion for all the shells, Windows, Linux, Mac, and everywhere. Think is a deep learning framework using ideas from functional programming and type annotations as the things that we were checking before. And it's compatible with your favorite libraries. So TensorFlow, PyTorch, all those things. Thank you very much. That's what I have for you. You can check the documentation here. Let's check some questions. If you have questions after we finish this meetup, you can also go to the GitHub repository and ask more questions there. There's a very active community. Yeah, that's what I have for you.
Thank you, Sebastian. Great talk, great overview of the framework itself. And we have a couple of questions from the attendees. And I'll start with the first one, which is, what were the motivations to create FastAPI? Due to its success, it was obviously needed.
The motivations. So FastAPI was actually built on top of the learnings from many other frameworks and tools. I was using a bunch of frameworks, a bunch of tools, combining them, combining plugins, combining ideas. And I was just trying to get something that will improve that further, learning from all those previous tools. And I also wanted to have something that was very simple to use and that was that provided like a very nice developer experience while having a great performance. But yeah, I think it's like all based on the shoulders of giants, on the path that all the previous frameworks and tools were already walking.
Excellent, excellent. So we have a question from someone who's probably thinking about using FastAPI, and he's asking, I'm thinking about developing a new API in Python. Why should I use FastAPI? What would be the main selling points when compared with other frameworks like Flask, Django?
Yeah, so well, if it is an API, then the main selling points will be this whole talk. There it will be like automatic data validation, serialization, documentation, that you get type checks and auto-completion everywhere in your code, and that you get some of the best performances available in Python. I guess those will be the main, the main points.
Excellent. So now we have a question that I also have. Which is being an open source maintainer, how hard is it to manage the project? How many time does it take from you? And you also have other open source projects. So how hard is it? How much time does it take from you every week and that kind of things?
So it was a lot of time in the beginning when I was like starting it, and actually like several months of just studying the standards and adding pull requests and stuff to the things that FastAPI is built on, like Pydantic and Starlet. It was a lot of work then. Now it's still a lot of work, but it's like mainly like on the weekends and things like that. But yeah, like the good thing is that the community helps a lot, and there's a lot of people that come to the GitHub repository and answer questions and like interact with others to help them solve their issues and their problems that in many cases are just like questions of how to do this or that with FastAPI. And that helps a lot. Also, a lot of people come and actually fix and add improvements to the frameworks itself, so that also helps a lot. But yeah, it's just like I like it and I use it, so I end up spending a lot of time with it.
Excellent. So a follow-up question to that one is, what are your tips for someone who wants to contribute to FastAPI or Typer?
So I actually have a whole blog post about that. The first thing that you can contribute to any open source framework is just documentation, because anyone that is new to a framework or new to a tool is going to have a fresh mindset and like a clean slate, and it's going to read it like with a very fresh mind. It's not going to know what the documentation says, so it's going to be able to detect the typos, to detect the inconsistencies in the words and in the things that are said, and it's going to be able to see like, hey, I'm not being able to understand this concept, and after struggling with it, it's probably going to be able to say like, maybe we can say this, and maybe we can restructure this information to make it easier to understand. That's one of the things that people that are new to any open source framework can help a lot. And at the same time, is one of the things that the people that are new to a framework or tool are going to be able to help even more than the current maintainers and the experts in the tool, because they have a very fresh mindset. Another thing that people can contribute a lot with FastAPI specifically is, for example, translations. There's currently an effort for translating FastAPI into several languages, including Portuguese. So if there are Portuguese speakers that also understand English enough to watch this talk, your contributions will be very welcome, and you can just go and translate like a single page, and it will be awesome. So yeah, it's actually very easy, and it's all quite well documented in the documentation sites, how to set up and how to start contributing and what will be something to do. Also, just like answering questions in the GitHub repositories, that helps a lot, because there's a lot of people asking things. So if you have some experience with it and you have used it a little bit, then you can help a lot just by answering some of those questions. I think those will be the main tips.
Awesome tips. And people usually go into open source projects and want to dive into the code itself and start messing around. And it's those are awesome tips just to dip your toe on the water. And one last question: what's next for FastAPI? Both short-term, long-term. What are your ideas? What are you planning on?
There's a bunch of things I want to have. Like there are some small things that have to be added that are like kind of technicalities, or like, for example, adding dependencies to the startup and shutdown events, things like that are like very specific to how FastAPI works underneath, and for like very, like, let's say, advanced use cases. But I want to add that. I want to add a bunch of documentation for how to do OAuth 2. For example, how to build an application that you can then authenticate with application X, as you do authenticate with Facebook or with Twitter or with GitHub, because all those tools are already there. They are already in place, and it gets all automatically documented in the user interface. But the documentation for how to do that and how to use it is still lacking a bit. So I want to improve on that. I also want to, at some point, build an automatic admin interface that is based on the same API, that is not like documented the API itself, but like helping with just admin creating and deleting, let's say, entities and things. And I have been recently playing around with building something that will be something in the middle between Pydantic and SQL Alchemy, so you can declare SQL Alchemy models with the standard Python type annotations. That's something that I have been playing on the side. It's not actually integrated it's not part of FastAPI itself, but will help a lot to be used with FastAPI. I think those are the main things.
Excellent. You should have some people that maybe get interested after your talk to actually contribute to some of those efforts in the near future. So,
awesome.
Sebastian, thank you so much for your talk. It was very interesting, and also thank you for answering our questions. And Isabel.
Thank you very much. Thank you, Ricardo. I think that's the first applause I've had since I started giving talks during the COVID. It's all silent here, and I'm showing memes, and I don't know if anyone is laughing at me.
Exactly, that's one of the caveats of doing online presentation.
Yeah, awesome. Thank you very much. Thank you, DevOps Porto, and thank you, Data Science Portugal, for the invitation. It was a pleasure to be with you all here.
Thank you, Sarah.
Thank you. Okay, so for last, I want to thank all of you for being on that side and having to deal with us. I also want to thank you, Ricardo, and the DevOps Porto community. I think we had a really great event. What do you think?
I think so, Isabel. I think it went very well. I think we should do it again sometime. And thank you for being such a good partner. And as we've said at the beginning, you can find both communities on those links. And thank you all for being present in this meetup.
Yeah, we are going to also share with you a survey that you can fill, so we can keep improving all of our even webinars and meetups. And please check all of your presentations in our GitHub page. You can follow this one and the previous ones there. So thank you, guys. See you soon.
Everyone.